All right, so continuing, um, there are uh, two major pathways for nutrient movement. The primary one is the um, with the actual water moving into the roots and up through the xylem, and that's a one-way street. New water and nutrients go into the roots, they get transported into the xylem, and then it moves up through the shoot tissue all the way out to the leaves. But then maybe things need to move again. Maybe they need to be relocated. And this remobilization or relocation can't go in the xylem because xylem is a one-way street. It only goes root to shoot all the way out to the leaves. And that's it. Water is one-way street. So if you need to move things or remobilize nutrients, it has to be done through the phloem, which is a two-way street. Phloem, wherever the sugars are going, the nutrients can basically hitchhike on the flow of sugars going to other parts of the plant. So some terminology, hopefully you know some of this already, but necrosis is death of cells that have gone to the point of stress, maybe chlorosis, which is the next one. They've been so chlorotic for a period of time they finally die. But necrosis is the death of cell due to some sort of injury, malnutrition, possibly infection or something of that sort. Chlorosis is an abnormally yellow color of the plant tissues. And what is abnormal? It's going to vary based on the plant you're talking about and the specific variety and even the climatic conditions in which you're growing it. So some plants might be extremely green, pine tree, forest green, very dark. And so they might be highly chlorotic when they're the color of a healthy, happy romaine lettuce. That for that particular plant, that might be considered very pale. So what you consider pale depends on the plant. Now, grapes tend to be a fairly dark leaf, and they tend to have a deep green color. And so with grape leaves, you can usually tell when they start to get more pale, more yellow than is normal. If it gets really yellow, you got a serious problem. It might be caused by insect damage. It might be caused by a nutrient deficiency like too little nitrogen, too little zinc, too little iron. There's a number of things that cause chlorosis. Some of them have unique symptoms that go along with the chlorosis, like a pattern of chlorosis. For example, the interveinal chlorosis is something that occurs with zinc deficiency, meaning the veins of the leaves stay darker green, but the leaf tissue between the veins, the interveinal tissue, becomes chlorotic or pale yellow. Again, that can be a mosaic virus of some sort. There's other things that could cause that, but zinc is a likely culprit if you see interveinal chlorosis. Marginal is the edges of the leaf. The margin is the outside edge of the leaf. And grapes have some serrations, indentations on many of the species. And so if you look at the margin, you might have chlorosis or necrosis around the edge of the leaf. Marginal means around the edge of the leaf. But you have to be careful there. A hot, dry wind blasting through for a few days on a freak weather pattern during midsummer can cause marginal necrosis and burn because the leaves just dried out so dang fast due to this hot, dry wind that came whipping through your vineyard for a few days. Chemicals, you spray some chemicals on and maybe it was a little too concentrated, maybe it was a little too warm when you sprayed it. Whatever the conditions are, marginal necrosis can be chemical burn. Salts in the water, poor quality water can cause marginal burn. So you're irrigating with a water that's either borderline good enough or definitely not good enough to be growing high quality vineyards. How much salt particular vine can take depends on other stresses the vine might be experiencing, the climatic conditions, the specific variety of rootstock and scion, et cetera, et cetera. All of those things play a factor in tweaking or adjusting how salt tolerant those plants might be. And marginal necrosis is definitely something that you might see with salt burn. Now, when the nutrients dissolve in water, they must be, or almost always, not every nutrient has to be, but most nutrient elements are in a cationic state. Cationic or anionic state. I should say in an ionic state, meaning they have a charge. A charge because they've either lost or gained one or more electrons. If they've lost one or more electrons, then they're left with a positive charge, and they're called cations. Things like potassium, K+. It is a positively charged nutrient, potassium, K+, that has lost one electron. Why does it lose an electron? It has to do with the stability of electrons in orbit. And when nutrients dissolve, they are salts when they're solids. And when the salts separate into their component parts to dissolve in water, one half ends up being a cation and one half ends up being an anion. And you can learn more about salts in a chemistry class. We talk about it a little bit in plant science, and certainly we talk more about it in fertilizer and plant nutrition class as well. But there are many, many, many salts that when people hear the word salt, they just think of, oh, that stuff you put on your corn on the cob at home or put on your chips with a little bit of salsa. That salt, yeah, that is a type of salt. That is table salt, otherwise known as sodium chloride. And when the sodium chloride dissolves in water, the sodium goes off with one less electron, so it's a cation. It has a positive charge. The chloride hangs on to that extra electron, that extra negative charge, so it is an anion. Common deficiencies, this is from the perspective of a Central Coast grower. So this is not something that you can apply to any location or any vineyard, but somebody who has a lot of acres in a lot of Central Coast regions developed this particular PowerPoint, and I've only modified it, I don't know, maybe half a dozen slides I've added, but this is based on his perspective. Nitrogen, potassium, zinc, and boron are the most common deficiencies in his experience. And I certainly would concur that my experience, which is fairly limited, but I certainly have talked to a lot of people over the years, and certainly these are things that I've heard by more than just one person. Iron, magnesium, manganese, and phosphorus, less common problems in this area. Problems with excess, nitrogen also, so deficiency for nitrogen, excess for nitrogen. That means the grower made a mistake with nitrogen. You should be monitoring that very carefully, but it's easy to do too much nitrogen. Chloride can be in excess. That often is a problem because of irrigation water. And some soils, depending on where you are, there can be high chloride levels in some soils, especially soils that don't get a lot of rainfall. So if you're in a more desert environment or a rain shadow environment where your climate just really doesn't get very much rain each year. And boron deficiency and excess. What did I say about boron? It's like threading a needle sometimes. I don't know if I use that phrase, but boron is the narrowest of the nutrients as far as I'm aware. From my perspective, it's the one you got to really watch carefully about the level, and your crop really needs it to be right. And when your grapes. It's really, really, really important to get good flowering and flower set and fruit set. To get a good, healthy crop, you need your boron to be right. Now, nitrogen is also very important to get right, but it's a bigger target. It's a little easier target to hit, but it's still easy to make a mistake, especially for organic growers. It's hard when you don't have the fine tweaking tools of high analysis conventional fertilizers. It's easier to put on exactly what you need when you need it with conventional production. With organic production, you're depending on the weather patterns this year to decompose your organic material that needs to slowly release the slow release fertilizer and give you the nitrogen that you need. There's no quick fix for organic production. You got to do it right the first time. Vines have a low demand for fertilizers, so unlike a lot of things we grow in the Central Coast, like lettuce and spinach and broccoli, well, especially lettuce and spinach, broccoli is a little on the lower side for its needs, but we grow a lot of things that need a lot of nitrogen and they need a lot of phosphate and potassium. You don't have to really add a bunch. You do need to add some things. You need to always make sure your crop is happy, your vineyard's happy, but you got to replenish the nitrogen that's used. You got to replenish the potassium that's used. You got to make sure that your boron is in that sweet spot that you need for your production. But other than that, it's not like the vegetable crops where you really are in an intense fertilizer routine. So young vines might need 0 to 20 pounds of nitrogen per year, with older vines 0 to 40 pounds per year. That's a pretty low number compared to what you would be putting in if you're doing baby leaf spinach all year in a vegetable production environment. You'd be using way more nitrogen than that per year per acre. So nitrogen, let's take another break before I get into the details